Pick up a textbook on discrete mathematics, and most likely you will discover the identity law, the domination law, the negation law, and the absorption law, or at least logical equivalents thereof. For instance, I've seen the domination law referred to as the universal bond law. But be that as it may, in propositional logic, in mathematical logic, these are logical equivalencies, or perhaps even better expressed as biconditionals. One reason they're useful is that if you have, for example, a long and complicated molecular sentence, sometimes you can, so to speak, simplify it into something shorter and more concise. But it is nevertheless still logically equivalent to your original statement. And this has an analogy with algebra. You may have a long, complicated equation, and you can simplify it, at least sometimes. You can group like terms, and you can factor, and so forth. And we'll do a couple of examples of the simplification process, but for now, let's look at these laws. We'll start with the identity law, and here I think truth tables are very helpful. With the identity law, you have something like P, and something that's always true. In other words, the tautology is logically equivalent to P itself. Then you have P or something that's always false. In other words, a contradiction that's logically equivalent to P itself. Alright, let's do a couple of truth tables. We'll start with the first one. So we have a conjunction, and P of course can be true or false, but a tautology is always true, and then we have our conjunction. True and true is true, false and true is false. And so, notice our first column and our third column, and they have exactly the same truth values, and this makes them, in propositional logic, logically equivalent. Second truth table, P can be true or false, but a contradiction is always false. And then we have our disjunction. True or false is true, false or false is false. And once again, first column, third column, the same exact truth values. And if you think about it, it makes sense. So if we take this statement here, we have a disjunction on the left-hand side, and in order for it to be true, you need at least one option to be true, but we know this option is false. So everything depends upon P. So if P is true, we have a true conjunction. If it's false, we don't. And so you can understand why the right-hand side is just P itself, because everything depends upon the truth value of P, okay? That's what makes it equivalent in propositional logic. Next we have the domination law. So here we have something like P or something that is always true. So what would that be logically equivalent to? Alternative, we can have P and something that's always false. What would that be logically equivalent to? Well, the first one must be true, must be always true, right? Because we have a disjunction. That option's true, we're good to go. And here, for the conjunction, that has to be false, always false. We'll do the first truth table. It's a disjunction, so P can be true or false. Tautology is always true. True or true is true, false or true is true. And so we only end up at true values. It's a tautology. Second truth table, P can be true or false. Contradiction is always false. We have a conjunction, true and false is false. False and false is false. We only end up at false values, false truth values. It's a contradiction. What about the negation law? So once again, we'll be dealing with tautologies, contradictions. So let's say we have P or not P. So what's that logically equivalent to? How about this? P and not P. So what's that logically equivalent to? You can think in terms of the law of excluded middle and the law of contradiction. So the first one, P or not P, well, it's always going to be true. So we have a tautology. It's equivalent to a tautology. The second one, it violates the law of contradiction. It's always false. It's logically impossible. So let's do the truth tables. First truth table. P can be true or false. Then we have a negation. So true to false, false to true. We have a disjunction. True or false is true. False or true is true. And so we have a tautology, something that's always necessarily true. Second truth table. P can be true or false. We have a negation. So true to false, false to true. Conjunction. True and false is false. False and true is false. So we end up only at false truth values. We have a contradiction. And finally, we have the absorption law. So what would that look like? So we can have something like P or parentheses P and Q. And if you think about it, it's going to have the same truth value as P itself. Okay? Or this one, P or parentheses P. Oh, sorry, it's the same one. P and, parentheses, P or Q, it's going to have the same exact truth values as P. Okay, let's do the first truth table. There are two atomic sentences, P and Q, so there are 4 total possibilities here. So we have true, 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 false, false, true, false, false. All right, conjunction. So this would be true, this would be false, false, false. Disjunction, so it would be with this column P or this column P and Q. So true, true, false, false. And notice, as expected, this column and this column, they have the same exact truth values. There's an equivalency there. Let's do the next truth table. So true, 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 false, false, true, false, false. Disjunction. So this is true, 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 false. Conjunction. P and this guy, P or Q. So true, true, false, false. And once again, this first column, this last column, we have the same exact truth values. There is indeed an equivalency.